This will be for the Kuta software worksheet, more properties of exponents. So if you have two numbers raised to an exponent and it's the same number, like in this case, they're both x's, then if they are multiplied by each other, you can just add the exponents. So x to the power of a times x to the power of e. You keep the x's, you just keep the x, and you add the exponents, a plus b. Now, if you have a number raised to an exponent, and you raise that to another exponent using parentheses, then you just multiply the exponents. So here we have x to the power of a to the power of b. You keep the x, and then you just multiply a times b for the exponent. Now, if you're dividing numbers with exponents, if the number matches, okay, for instance, we both have x's here. This is x to the power of a divided by x to the power of b. Again, you keep the x, but instead of adding the exponents, you subtract the exponents going down. So the exponent here is going to be a minus b. So you just subtract the exponents going down. Now, if you have two numbers or more multiplied by each other, and using parentheses, that whole product is raised to an exponent, that exponent actually gets applied to both numbers. Okay? So if you have x times y to the power of a, that's going to be x to the power of a times y to the power of a. So that exponent gets applied to both numbers. And if you have a negative exponent, you can take the entire number with the exponent and shift the whole thing into the numerator or denominator. Okay, so in this case, we have 1 over x to the power of negative a. We can take this whole thing and move it to the numerator. And all we have to do is change the sign on the exponent. So 1 over x to the negative a is just going to be x to the positive a. Okay, if you take this whole thing and move it to the numerator, you change the sign. The same holds true with a negative exponent in the numerator. Okay, here we have x to the power of negative a. And you can put this over 1. It's the same thing. We can take this whole thing and move it to the denominator. Okay, and all we have to do is change the sign, the plus minus sign on the exponent. So x to the negative a divided by 1 is the same as 1 over x to the positive a. So the negative a became positive a, and we just moved it to the denominator. And finally, anything to the power of 0 equals 1. Okay, so x to the 0 equals 1. And if you see something in parentheses, it doesn't matter what is in the parentheses, okay? Even if it's x times y times z, if it's raised to the power of 0, it's going to be 1. Okay, the instructions say to simplify, and your answer should contain only positive exponents. All right, let's look at number 1. We have two numbers multiplied by each other. Okay, we said before, since the two x's match, we keep the x, and then we just add the exponents. So negative 2 plus negative 3 is going to be negative 5. Okay, and that is still raised to the power of 4. And we said if we have something with an exponent raised to another exponent, you just multiply the exponents. So you want to keep the x, and negative 5 times 4 is negative 20. Okay, and finally we said for negative exponents, you can shift the whole thing into the numerator or denominator. So I am going to put x to the negative 20 divided by 1. And what I'm going to do is take this whole thing and move it into the denominator and then change the plus minus sign on the exponent. So we have 1 in the numerator, and x to the negative 20 becomes x to the positive 20. And that is the most simplified answer. Okay, you can check your answers on pages 3 and 4. All right, let's look at number 3. We have n to the third raised to the power of 3. So we keep the n, and the exponents get multiplied in this case. 3 times 3 is 9. Okay, and that's going to be times 2 to the n times 2n to the negative 1. All right. Now we can move these are all multiplied, so we can move the 2 in the front just to make it a little more easy to look at here. So that's going to be 2 times n to the 9th times n to the negative 1. Okay, so now we can see that we both have n's right here. We keep the 2, we keep the n, and the exponents get added. 9 plus negative 1 is just 8. Final answer. All right, and it matches the answer they got for number 3. All right, let's look at number 5. It's not as bad as it looks. These are all multiplied in the numerator. Let's take care of that first. For the constant terms, we have 2 times 4, which is 8. And 8 times 3 is going to be 24. Okay, now for the exponents, let's look at the x's first. Okay, we'll keep the x, and we're adding exponents. So x squared, let me get rid of this here. X squared, 2 plus 2 is 4. And the 1 on the end is the same as x to the first power. 2 plus 2 is 4, plus 1 is 5. So that's going to be x to the 5th. And now let's do the y's. Okay, there's only 2 y's. We have y to the 4th and y to the 4th. 4 plus 4 is just 8. Okay, in the denominator, we have a 3. X to the negative 3, and y squared. Okay, let's look at the constants first. 24 divided by 3 is just 8. And for the x's, they are divided, so we subtract the exponents going down. 5 minus negative 3. Remember, 2 negatives in a row is positive. So 5 minus negative 3 is 5 plus 3. So that's an 8. That's the exponent on the x. And then for the y's, 8 minus 2 is 6. Final answer. All right, number 11. We have 2m squared to the negative 1. We can certainly distribute this negative 1 if we wanted to. But what I would like to do is, since this whole thing is raised to the power of negative 1, I'm going to take this whole thing and shift it to the denominator. Okay? So instead of 2m squared to the negative 1, I am going to make it 2m squared parentheses to the positive 1. Okay, so I move this whole thing into the denominator. Okay, so basically the only thing left in the numerator is a 1. And now we can certainly distribute this 1, but it doesn't do anything. I'll do the extra step just to show you. There's a 1 in the numerator. There's an m squared. And of course, these are just multiplied. Distributing the 1 That's going to be 2 to the first power. So that's times 2 to the first power. And 1 times 2 is 2, so it's still m squared. All right? So really, this first power distributing did nothing. It was the same as it was already. All right, and then let's see. We have the 1 in the numerator. 2 to the first power is just 2. And m squared times m squared, we're going to just add 2 plus 2 and get m to the 4th. So that's it for number 11. All right, number 15, almost the same thing. I can certainly distribute this negative 3, but I would rather have it positive 3. So we have ba to the 4th in the numerator. And I'm going to make a denominator, and I'm going to move this whole thing into the denominator. So parentheses, 2ba to the 4th. And instead of negative 3, that's going to become positive 3. So I move the whole thing down, and I change the plus minus sign on the exponent. All right. All right, so we have ba to the 4th in the numerator. And distributing the 3 in the denominator. I'm going to try and line up the letters. Okay, distributing the 3. So that's 2 to the 3rd. And then distributing the b. This is b to the 1st, right? So distributing the 3, it's b to the 1 times 3, so that's b to the 3rd. And finally, a to the 4th times 3, it's going to be a to the 12th. All right, so these are just multiplied in the denominator. All right, let's see. We'll do everything one at a time. 2 to the 3rd is just 8. That's in the denominator. And let's look at the b's. When there's no exponent, it's automatically 1. All right, so we have the b. And when dividing, we said you subtract exponents. So the exponents on the b, 1 minus 3, that's negative 2. And we have the a. The exponents on the a's, we're dividing, so we subtract exponents. 4 minus 12, that's negative 8. All right, and they said no negative exponents, so we can just shift each of these into the denominator. B to the negative 2, if you move it down, it's b to the positive 2. A to the negative 8, if you move it down, that's a to the positive 8. The only thing left in the numerator is a 1. And if you want to write it in alphabetical order, you put the number coefficient first, and then a to the 8th, and b to the 2nd, or b squared. And that's it. All right, number 21. Like I keep saying, you can certainly distribute this negative 4 if you want to, but I would rather make it positive. So I'm going to take this whole thing and move it to the denominator. Okay, so in the denominator, we have 2p squared. I'm going to take this whole thing. Let me recopy it. All right, 2pm to the negative 1. So we have 2pm to the negative 1 times q to the 0. And that whole thing, parentheses, instead of negative 4, now it is positive 4. Okay, so I just move this whole thing, and I change the main exponent. So this is gone. All right, and m to the negative 1, I might as well move that down as well. So instead of m to the negative 1, that's going to be m to the positive 1, which is really just the same as m. So I move that down as well. So the only thing left in the numerator is the 2 and the p to the third. All right, let's clean this up a little bit. Numerator, we have 2p to the third. And the denominator, let's see. We have to distribute this 4 to each one of these. So 4 is applied to the 2, that's 2 to the fourth. And then p, this is p to the first. So it's going to be p to the 1 times 4, that's p to the fourth. M to the negative 1 times 4 is going to be m to the negative 4. And q to the 0 times 4, well, 0 times 4 is still 0, so that's q to the 0. All right. And what else do we have here? We have 2pq squared. And we have m to the first power, or just m. You can write m to the first if you like. All right, let's clean this up a little bit. The order that you do these things, it doesn't always matter that much. But these are all multiplied on the bottom. There's a 2 on the top and a 2 right here. So I'm going to cancel those 2's. And q to the 0 is just 1, and times 1 doesn't do anything, so I can cancel q to the 0 as well. So let's see, numerator, we have p to the third. Denominator, we have 2 to the fourth. 2 times 2 is 4, times 2 is 8, times 2 is 16. So 2 to the fourth gives us 16. All right, again, these are all multiplied. This is p to the first, so we have p to the fourth times p to the first, and we just add the 4 plus 1, so that's going to be p to the fifth. All right, cross out p, and cross out p. For the m's, let's see the m's. I'm going to write the m first. We have m to the negative 4 times n to the first. So we just add negative 4 plus 1. So that's going to be m to the negative 3. Cross that off. Cross that off. Okay. And now, all that's left is q squared. All right, almost done. Let's see. M to the negative 3, if we move that up, that's going to be m to the positive 3. And as far as the p's are concerned, if you want me to line them up, we have p to the third in the numerator. Okay, and I'll line it up with the other p so it's easier to see, but you don't have to. All right, let's see here, let's see. So we still have a fraction. All right, the only number or constant is 16. That's in the denominator. So I will write 16 in the denominator. We have the p's here, so I'll write the p. And then the exponent, since we're dividing, we subtract the exponent 3 minus 5. That's going to be negative 2. So p to the negative 2, cross those off. Nothing we can do with these. They're both already positive, so m to the third over q squared. M to the third over q squared. And finally, no negatives, so we take p to the negative 2, and we're going to move it down. That's going to be p to the positive 2. All right, so if you want to clean it up and write it in alphabetical order, we have m to the third in the numerator. We have a 16 in the denominator, and p squared, q squared. That's it. All right, and one hint on number 22, this is almost a trick question. Okay, you see this whole mess right here in the numerator. There's parentheses around this. This whole mess is raised to the power of 0. Anything raised to the power of 0 is 1. So this entire mess in the numerator is actually just 1. Okay, and then you can finish it from there.